What up, peeps? It's Mr. Worthen here. We're on to day 4 of Unit 9, which is quotient power rules. And all quotient means, if you remember, is division. Well, yesterday, you guys were multiplying. And when we were multiplying, we multiplied coefficients like we would ever since 3rd grade. However, we had to add exponents if the bases were the same. Well, today is the same idea, except because when we divide, we're going to divide coefficients or reduce fractions just like we would any other time. But with our like bases, we're actually going to subtract the exponents. So one more time. When we multiplied, we added exponents. But when we divide, we subtract them. All right, so here's the actual fanciness. X to the A over X to the B. An important part is the bases are the same, because if they are not the same, we're not going to subtract. If this guy was a Y, this rule doesn't work, or wouldn't apply. But if the bases are the same, you are allowed to subtract the exponents. Now, that's dangerous, because anytime you subtract, you have the potential of creating negative numbers. And we don't want negative exponents. You don't know it yet, but day 5 is going to be all about negative exponents. We kind of force them on you and expect you to deal with them. But for today, I'm going to tell you, you do not want a negative exponent. Don't create it. And I'll explain what I mean in a minute with some examples. Well then, additionally, we're going to throw at you power of a quotient. So if I take x to the a over y to the b, and again, those bases are not the same, x and y, so I can't just subtract the a and b, which is going to happen. You're going to be playing with x, y, z's, a, b, c's. It'll happen. But if I raise that whole chunk of chicken to a separate power c, it's almost like the distributive property. It just means that that c is going to, again, exponent raised to an exponent means we multiply those. So AC over, well, that c also applies to this guy, y to the exponent raised to an exponent, BC. So it's very similar to the distributive property. That c has got to go to each piece of this problem. Well, now be careful. What if there are more than one piece of multiplication? AKA, what if there are multiple products up here? An x and a y. And then down here, there's a and a b. That means that c's got to go to each product, each piece of multiplication within that. And it's going to get a little sassy, but that's the basic stuff. Let's play with a few of these. So, real basic. X to the 5th over x to the 3rd. Are the bases the same? That's the first thing you got to ask. And if they are, I'm allowed to just subtract those bases. Now, I've warned you that sometimes we'll create negative exponents, and we don't want that. I'm going to show you a little bit more visual way of doing this problem. X to the 5th just means x times x times x times x times x. Might have said one too many, sorry. But there's 5 of them up there, all connected with multiplication. And then down here, x to the 3rd means x times x times x. Well, just like any other division problem, if you have 4 over 4, don't those cancel and create 1? We're going to do the same thing with x's and y's and a's and b's. You got an x on top, you got an x on bottom, they cancel each other out. You got an x on top, you got an x on bottom, they cancel each other out. You got an x on top, you got an x on bottom, they cancel each other out. I kind of talk about this like in my class, the Civil War. North, top versus south. And they're going to fight. And a big piece of this is who wins? Does the top win or does the bottom win? Is there anything left on the bottom here? Yes, a 1. Remember how I said it cancels to 1? Yes, it cancels to 1, but do I need the 1? What's left on top? X squared. Do I need the 1 on the bottom? No, it doesn't change anything. So I don't need to write that, even though it's really secretly there. So we end up with the same answer whether I use the subtraction or just north-south fighting. And that's going to come into play down the road. Especially if I were to get a negative exponent, I'm going to say this guy is the better way to go about it. I'm going to say number 2 causes us a lot of problems. And it's because we confuse the 7 as a coefficient versus a base. Because the 7 is raised to a power, he is no longer a coefficient. Over here, look at 3. That 3 is a coefficient because he is not raised to a power. That 6 applies to the w, not the 3. Negative 3, sorry. But in this case, on number 2, that 7 is not a coefficient. He is a base. He's got an exponent. So, using my same rule, I could go 7 to the 9th. Sorry, 7 to the 9th divided by 7 to the 5th equals 7 to the 9 minus 5, which is just 7 to the 4th. Now, theoretically, I could do 7 to the 4th in my calculator and get some big crazy number. If it's this kind of problem, we are generally not going to make you multiply that out. Theoretically, in a multiple choice test, could they have answers 7 to the 4th? Sure. Or could they make you multiply it out and have some big old answer? I don't know what 7 to the 4th is, but we could do it. Likewise, I'm going to show it one more time, and this is going to get old real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sevens up top. 5 sevens on the bottom, all connected with multiplication because it's an exponent. And then we just end up fighting. Boom, boom. Boom, boom. Boom, boom. Boom, boom. Boom, boom. And we end up with 4 sevens being multiplied, which is 7 to the 4th. Now, I'm not going to want to write that out every time, but the concept is you had 9 on top, you had 5 on bottom, so I know the top of this fraction is going to win. And after they go to war, how many are going to be left? 4. Now again, when the bottom wins, that gets a little sketchier, and I'll show you in just a sec. All right, so I look at number 3. We finally throw some coefficients at you. And again, if you remember day 2 versus day 3. I'm sorry, my fault. Day 1 versus day 2. On day 1, we were multiplying and adding. On day 2, we were multiplying coefficients and then adding exponents. So the fact that we're doing both of these in one day, we're hoping you got day 1 and 2 down solid because we're applying both of them right now. So when I look at this problem, there's a lot going on. What you first need to identify is that those are coefficients, no different than, hang on, I'm going to mess with you a little bit, give me a sec. Like in 5th grade, we started playing with fractions, and we gave you the fraction negative 3 over 9. Sorry, my pen's not big enough. We gave you the fraction negative 3 over 9, and you had to simplify. And you said that was negative 1 over 3. Well, it's no different right now, but we're adding more stuff on top of it, and that's what gets confusing. Do I subtract coefficients, or do I divide them? Do I divide exponents, or do I subtract them? You've got to get these rules down solidly, otherwise you're going to end up questioning yourself and being confused. So anyways, just looking at this piece of the problem, I know that's going to be negative 1 over 3 from 5th grade. Now I got to go look at my variables and treat them differently because they are bases, not coefficients. When I look at the w's, I have 6 on top and 5 on bottom. So who's going to win? The top, because there's more of them. How many are going to be left after they fight? There's going to be a single w left on top. Now I wrote the 1 up there as an exponent, but if I just have a single w, I don't need that 1. Don't get used to writing it. It's not wrong, but you'll never see it in multiple choice land. So I've taken care of coefficients. I've taken care of w's. Now I've got to play with x's. Well, this is the first time that if I used this rule, sorry, let me change colors. If If I used this rule and did 4 minus 6, I would get negative 2. And my advice to you is do not create negative exponents. Just go right back to the whole north versus south thing. Top has 4 x's, bottom has 6. Who's going to win? The bottom, because they got more. What's that mean? That the x's that are left are going to be on bottom. I'm going to just play with the x's here. X, 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 X. 4 of them on top. 6 of them on bottom. And again, you're not going to want to draw this out every time, but just the concept, the mind, the thought behind it is, I think, important. Cancel, cancel. Cancel, cancel. Cancel, cancel. Cancel, cancel. So you're left with these 2 x's, but where they are at is important. They are not on the top. They are on the bottom, which is why we end up with an x squared on bottom. And again, this is why I don't love this rule, because some of you guys are going to say, oh, 4 minus 6 is negative 2, and you're going to try to put a negative there. And that is wrong. And you don't know it yet, because day 5 is we're going to play with negative exponents more. But don't create negative exponents. Just let them fight. Let them go through their gig. Who wins, top or bottom, how many are left? I think that's the easiest way to go about this. Okay, I'm going to pause for a second. Actually, you need to pause, because I'm not going to. Hit pause. Do those 3 problems. Don't just copy. It does you no good. Take a peek, take a try, see if you know what you're doing. Okay, hopefully you tried these on your own and aren't just continuing the video and copying down, because that doesn't really help you that much. I had 4 on top. There's no exponent. Sure there is. There's a 1. We just don't write it. So I had 4 on top, 1 on bottom, which left 3 y's on top. No big deal. Actually, I shouldn't say that. The fact that he doesn't have an exponent actually confuses you guys sometimes a little bit more than if that was a 2 or a 3. You'd be more comfortable if there was a number there. Know that if there's no exponent, it's just a 1. Write it in there. I got no problem with it. We just won't write it in there for you. When you looked at the next one, first coefficients, and again, the order doesn't matter, but keeping the coefficients separate from the bases is super, super important. I got 8 over 2. Well, that's just normal 4 over 1. I didn't put the over 1 here because there was nothing left on the bottom. Is it there still? Yeah. How old are you? 15. Are you 15 over 1? Technically, what would you ever say? Hey, I'm 15 over 1. How you doing? Simple. So don't get used to writing it even though it's technically not wrong. Then I played with the ends. I had 7 on top, 3 on bottom. Top was going to win. After they fought, we ended up with 4 m's left. So there was no bottom in this case as well. However, when we got to C, we finally, the bottom, won a few of these battles. When I looked at 16 and 12, normal numbers, just coefficients, do the normal thing. Reduce it as though it was a fraction from 5th grade. 4 goes into 16, 4 times. 4 goes into 12, 3 times. Can't take this any further. Now play with A's. You got 4 A's on top. Be careful, because I see this a lot. Who does that to apply to? Only the B. He does not go to that A as well. The A has its own exponent, and it's a 1. So I had 4 on top, 1 on bottom. That leaves me with 3 A's left on top. Go to your B's, 3 on top, 2 on bottom. That leaves you with a single B left on top. And again, is there a 1 there? Yes. Will we write it? No. Well, I think the C's are a little bit interesting because you haven't seen this yet. The C's had nobody to battle with. There were no C's on top, so they didn't get into a fight. That means there's still all 4 of them chilling down here on the bottom. Nothing changed with them. They didn't have anybody to play with. All right. Switch gears. Now we're spicing this up a little bit. Now I've got a fraction raised to an exponent. My advice to you would be, first, can I reduce that fraction? Is there any fighting, canceling, reducing that could go on there? And I see a coefficient of 2 and no coefficient down here, so nothing can go on there. I see a D up here, but no D's down there, nothing I can play with that. C's down here, no C's on top, so there is no reducing that I can do at this point. But you're going to find out, if you do that, if you can do that, it's going to make life a lot easier down the road. Okay, a huge piece of this is how many individuals, how many products, if I was being fancy, does that for apply to? And you really got to see this carefully. That 2 is a separate product from that D. So that exponent of 4 is going to have to go to the 2 and the D, as well as the C down here. So I'm going to write this out, and some of you guys are going to get good and try to shortcut the system a little bit, and I'm going to tell you you need to be real careful with that. But this ends up being 2 to the 4th, and I write it out every time. I don't try to do 2 to the 4th and then move on. Just write it. And then D to the, do some erasing here, his exponent was a 1, and 4, exponent raised to an exponent means multiply. 4 times 1 is 4. Over, got to throw that 4 down here to the C as well. Exponent raised to an exponent means multiply those guys. So 4 times 4 is 16. Now, we've done a lot of good, but you're technically not done because I can evaluate that. 2 to the 4th means 2 times 2 times 2 times 2, which is just 2, 4, 8, 16. Are there any D's on the bottom to fight? Nope. So he stays. Are there any C's on the top to fight? Nope. He stays. And that is as far as I can go with that bad boy. Let's go check out 5, because we finally get to do a little reducing first. And it's a little, but it's important. If you just, I'm going to go back to my first thing, how many pieces of this product does that 4 apply to? Let me see if I can make this bigger. I feel like it's tiny. How many pieces of that 4 does this apply to? 1, 2, 3, 4. There are 4 different pieces of the product. It's almost like terms, like when we did distributive property back in the day. That's not technically correct to say, but the idea behind it is the same. Now, if you don't do what I told you to do on the previous problem and try to reduce, don't write this down. Do not write this down. You would end up with 4 to the 4th, m to the 8th, 4 times 2 is 8, over 12 to the 4th, and n to the 20th. Well, when I have to evaluate that, 12 to the 4th is some gigantic, ugly, nasty number. 4 to the 4th is still not that friendly, and when I'm done with that, I would then have to go reduce whatever those 2 ugly, ugly numbers are. And that doesn't sound like fun. So, what can we do instead? Reduce first if you can. I look at this, back in the day when we did PEMDAS, isn't it do what's in the parentheses first? In this case, I can't play with the m's and n's. They're not like bases, so I can't do anything. But 4 and 12 are coefficients. Those are normal numbers. I can do the normal division, reducing process. And when I do that, we'll rewrite the whole thing. That 4 is still out there. The m squared is still there. The n to the 5th is still there. And when I reduce 4 over 12, 4 goes into 4 once, 4 goes into 12 3 times, we end up with 1/3. Well, the reality is, do I really need the 1 on top since there's already an m? If there was nothing left on top, I would need that 1. But I got an m squared out there. I know there's really 1 m squared out there. So if you want to write it, go ahead, but you generally won't see it. Well, what did that do for me? Now that 4 only applies to 1, 2, 3 guys, and the numbers, the coefficients, are significantly smaller. So I'm going to redo this. M squared to the 4th, exponent to exponent means multiply. And the hard part of all this is you're going to get the rules confused if you aren't truly practicing and thinking about this. Exponent to the exponent means multiply. Go back to day 3, when you did m squared times m to the fourth, you added the exponents. But that is not the same as this. So being careful about which type of operation is going on is important. Over. That 3 has got to be raised to the fourth power. And the n to the fifth, raised to the fourth, exponent to exponent, multiply. Can't stop there because that can be simplified, evaluated. M to the eighth over 3 to the fourth is 3 times 3 times 3 times 3, which ends up being 9 times 9, which is 81. And again, that's something you should have gotten good at in terms of the first couple of days. You got to be able to plug that stuff into your calculator. Anytime you're playing with exponents, numbers can get real big real quick. Can't lose the n to the 20th. And now I got to ask, am I done? Is there any reducing of coefficients that I can do? 1 over 81? No. Do I need the 1? No. I got m's on top, no m's on bottom. Nothing I can do. I got n's on bottom, no n's on top, nothing I can do. And I'm donezo. Not Denzel, donezo. I'm on las fiestas, los niños. This bad boy is cray-cray. We got a lot going on in this problem. And this is where we're kind of headed. We've been a little holding your hand crossing the street up to this point. Number 6 is no joke. There's a lot going on. From the exponent to within there's another set of exponents to I got p's on top and p's on bottom, r's on tops, r's on bottoms. I got 18 and 12 that can be reduced. There is a lot. So no joke here. Let's go one step at a time. I'm going to argue the first thing you should do, and you got a little flexibility here. But I'm going to say I don't like parentheses inside of parentheses. PEMDAS tells me parentheses first. Well, if there's parentheses in your parentheses, take care of that guy first. So, I don't want to lose my 3, so I'm going to leave it out there. I'm going to leave the top alone and just focus on those parentheses on the bottom. That squared does not apply to this 12 because the 12 is not in the parentheses. So that squared only applies to the r and the p squared. So I'm going to let the 12 chill. P squared, raised to the second, exponent to exponent, multiply. R to the first, raised to the second, 2 times 1 is 2. So we end up with r squared down there. Where'd the parentheses go? Well, it's still 12 times whatever this is. Isn't this still 12 times whatever that was? No different. I didn't need them after I got rid of this square. All right, the next thing a lot of you might want to do, which is not a great idea, is now let's go throw the 3 in here. You're going to end up with huge numbers, a lot more work than you need. Go back to what I said on that very first problem, number 4. If you can, reduce. It'll make your life so much easier. So again, I'm just going to rewrite this whole chunk of chicken, leave that 3 out there, and now let's start reducing. Coefficient, coefficient. Normal numbers from 5th grade, reduce them. What goes into 18 and 12? Again, those of you who are not great with your reducing or division, that kind of stuff, you better get good at using the calculator because it can save your bootay. 6 goes into 18 3 times. 6 goes into 12 2 times. So I've reduced coefficients, that part's taken care of. Now I got to go start playing with the p's. There is a single p on top. That 5 is only to the r. 1 p on top, 4 on bottom. Don't create negative exponents. 1 on top, 4 on bottom. Bottom is going to win. There's going to be 3 left because they fought. And now I've taken care of those. Go play with r's. I got 5 on top, 2 on bottom. There's more on top, so I know the r's that are remaining will be on top. And how many of them are left? At 5 on top, 2 on bottom. When they fight, there'll be 3 r's left on top. I've done so much work before I even played with this guy that will make my life 100 times easier if you will actually try to reduce when you can. All right, so now I got to deal with this bad boy outside. How many pieces of this quotient slash product are we going to play with? 1, 2, 3, 4. that cubed, raised to the third power, has got to go to 4 different individuals. And again, I'm warning you, some of you are going to try to do 3 to the third in your head or with your calculator, and I think you're smarter to just throw it in there, and we'll deal with that part of it later. That is a 3. It's raised to the third power. Just write it. We'll deal with it later. Now focus on your bases. R to the third, raised to the third, exponent to the exponent means multiply. Go downtown. 2 to the third, just write it. Bases, p to the third, raised to the third, got to multiply. And we still ain't it. Because I got to be able to evaluate those guys. They are evaluatable. R to the ninth, I can't do anything with. I don't know what R is. But 3 to the third, I can do. 3 times 3 times 3 is 27. R to the ninth, just chilling. 2 to the third is 2 times 2 times 2, which is ocho. ESPN 8, the ocho. P to the ninth. Now, the final stage of this is, can I simplify any more? Can I reduce this fraction anymore? 27 over 8. There is nothing that goes into both of those, so that part of it's done. I look at the R's. I got 9 of them on top. There are no R's on bottom, so no Civil War. I got P to the ninth on bottom. No P's on top. No Civil War. I have checked, but that's as far as I can go. That is the simplified form of that problem. All right, you got a couple for you. Again, I just really hope you guys are pausing. If you're not and just copying, you're really not getting enough. You got to practice to see where you're struggling, just like anything else. Playing an instrument, a sport. If you're not practicing, you're not getting better. Pause the video. Try these couple. Hopefully you attempted those. Part D, fairly straightforward. There was nothing I could reduce to begin with. I just threw that exponent into both of those guys. There were no coefficients to mess with. Sorry, there was a 1, but 1 times 1 times 1 is still 1. So it was pretty straightforward. E was not so straightforward. I'm going to throw it out there and let you look at it. But again, step 1, I dealt with that guy to get him. Step 2, I reduced that big old fraction and ended up with this. Step 3, I threw the exponent in to get this. And step 4, I evaluated my coefficients to end up with my final answer. Again, at the end of these problems, you got to ask, is there any more that I can do? Can I reduce the coefficients? Is there any top bottom that I can cancel? And in this case, we good. Get after it, kids. Oh, sorry, I forgot I had one more. Good golly, missed them all. So I got some function notation, and we're just trying to give this to you because you'll see it from time to time, and it scares you guys, but it's no different. They're telling me the function f of x is negative 3x to the 5th. G of x is 27x to the 9th. Defining h of x, some other function, to be the f divided by the g, we'll just rewrite all that. What is f of x? So h of x is going to equal f of x. Well, what's f of x? Negative 3x to the 5th over g of x, which is 27x to the 9th. And it's just a fancier way of writing the types of problems you played with already. Oops, I forgot my F. My bad. And now you just grind as we have. Coefficient divided by coefficient ends up being negative 1 over 9. 3 goes to that once, 3 goes to that 9 times. I got 5 x's on top, I got 9 on bottom. Bottom's going to win. There's going to be 4 left. And we got donezo. I will throw out one more thing. This negative is a little sassy sometimes. You might say, I'm okay with you leaving it on top, but you might see it written in a multiple choice answer as negative 1 over 9 to the 4th. Sorry, 9x to the 4th. So theoretically, that negative that's chilling up top could just be out in front. All this is saying, this negative, is that that whole number, whatever it is going to be a negative number. So that's a possibility to see. We are fine if you leave it like that. Just be prepared for both. All right, again, one more pause. Sorry this is running long. I'm a little long-winded, but I hope you got something out of it. Again, k of x was just g over h. So I took g over h, reduced. Where'd the bottom go? It's still there, but like I said before, why would you leave a 1 on the bottom when you don't need it? Yes, you're 15. You ain't going to say you're 15 over 1. Now, if the only thing that's left on top is a 1, you absolutely need it, so watch out for that. Take care, kids. Keep grinding. I know this ain't easy, but you guys are doing a great job. Stay on top of it. Check in teams daily. Take attendance on your distance. Peace.